Hi, my name is Liz Steininger. I'm the CEO and Managing Director at Least Authority, and I'm going to talk to you today about ZCAPs, Zero Knowledge Access Passes. And this is something that we have created basically, and which I'll tell you about now, to enable privacy and required data collection. And I'll tell you more about how this all works. So thanks for joining, and I'm going to go ahead and go through the slides now. So about what I'm going to talk about today, this is a bit of an overview. I'm going to talk about who we are, and that's referring to Least Authority and the other parties who, and basically our company. I'm going to talk about ZCAPs, give you a quick introduction to what they are so that that can give you a little bit of context before I go in deeper into our particular use case and the problem that we're solving. After that, I'll also talk to you about how private storage works and where basically ZCAPs came from, adapting them from Privacy Pass, and then the result of ZCAPs in practice and just looking ahead. So with that, I will get into the details of who we are. So Least Authority is a company that was founded a while back in 2011, but moved to Germany in 2016. We're committed to building and supporting the development of usable technology solutions and ethical business practices to advance digital security and preserve privacy as a fundamental human right. Now, that's a lot, but basically we care about privacy and security. We see privacy as a fundamental human right, and so we want to make that more clear within our technology, and we do that by helping other people make their technology more secure and take considerations around privacy. That's security consulting that we do. And we also achieve our mission through product development. So creating new products or building products off of existing technology that helps people to have more privacy controls, basically enhance and respect their rights to privacy within the technology. And so, like I said, we do this through product development too. And then because we care about these topics so much, we also do community contribution projects. And so this can be a range of things from, grant work with special at-risk users to also, contributing our code as open source, publishing papers, doing all kinds of other things where, we do it more for the sake of contributing to the community along with the other business that we do. So this is the principle of least authority. Every program and every privileged user of the system should operate using the least amount of privilege necessary to complete the job. And this is one of the things that we keep in mind when we do our work. So now I'm going to give you a quick introduction to ZCAPs. So what are ZCAPs? ZCAPs, that acronym stands for Zero Knowledge Access Passes, an anonymous token-based authentication protocol that we use. And it's a modified version of Privacy Pass. There's a link here, and I'll also tell you a little bit more about what Privacy Pass is too. And we adapted it to be used by private storage, which I'll also tell you more about. So our use case and our problem. Our use case is with private storage. Private storage is a product that we are developing right now. It's a hosted and managed version of Tahoe LAFS. I say LAFS, but it stands for Least Authority File Store. And Tahoe LAFS is an open source distributed secure storage solution. It has all of this is done with a focus of privacy by design, with the angle of data minimization, which means that we try to collect as little personal data as possible, and it's enabled by security by design. So this idea of building security into the system from the very beginning design stages, and not trying to make security by policy or security later in the system. All of this results in us storing data without collecting personal data. So we store data storage, and we do this without collecting personal data about people. But this creates a problem for us to process payments for our product, especially fiat currency payments. We need to collect personal data. This is required of us. We need to collect the name of people. We need to collect an email address, location, especially for VAT in the case of the EU, and transactional data. And then we also have to share it with some other companies who help us to process these payments, like Stripe and ChargeBee. And this results in us collecting personal data that is actually unnecessary for the service itself. So in order to store the data for people, we don't need this personal data. We only need this personal data just to process the payments. So how does private storage work in a little bit more detail? So like I said, our use case of private storage in Tahoe LAFS. Private storage, like I said, is utilizing Tahoe LAFS, and it has the following features: client-side encryption, distribution of sharded ciphertext. It's not ACL, which stands for Access Control List. There's no user accounts, no passwords, and this is where I was making reference that we don't collect personal data in order to provide the service. And then OCAP, it's an OCAP-based system instead of ACL. So this is an object capability access type system. And this is where the access is based on possession of the capability string. And this is also the decryption key. So the files and directories are encrypted on the client side, like I said. And so this means that locally the encryption is done. And basically that encryption key is possessed by the user who wants to store data, and it's not possessed by us as a service. So this is where we can give that security and privacy by design. And so the shards of ciphertext then get distributed on servers in a grid. I guess I should just add that part there that once the data is encrypted, it becomes ciphertext, and then that ciphertext is cut up into shards. I shouldn't say cut, created, shards are created, and then it gets distributed on servers, and the collection of servers that are designated to receive that data is referred to as a grid in Tahoe Labs, and the Tahoe Labs protocol does not require money for this to happen. So this kind of product idea with the exchange of money isn't baked into the Tahoe Labs protocol on its own. And so no user accounts means that we needed to come up with a different approach for pay for storage. So in other storage solutions, if you have email address, users, maybe username and password that people sign in with, then it's easier to associate their their usage of the system with maybe an account or something. But because we don't have accounts and we have a capability-based system, we had to be a little bit more creative. So we needed a way to ensure that each shard being received by our storage servers is paid for. And like I said, Tahoe Labs, the protocol doesn't have the money exchange in it already. And so, but the protocol does include leases on these shards. So a bit of data about the shard and how long it needs to stay alive and basically do things on the storage servers. So we thought that we could use this to our advantage. So adapting privacy paths. Oh, I'm sorry, I missed a slide. Okay, so before I go to adapting privacy paths, let's talk about how we modified Tahoe Labs for private storage. So we modified the private storage servers, to require ZCAPs, and like I mentioned, these anonymous tokens. And the leases for shards are set based on ZCAPs. Without ZCAPs, the storage servers will not allow the shards to be stored. So we added this extra layer on top of this to be able to kind of do that access control. So if somebody hasn't paid, then we won't store their data for them. But also doing this in, like I said, in a way that it doesn't have to be based on accounts. So, okay, now adapting privacy paths. Privacy paths originally came from Cloudflare and Tor browsers, an issue that was there. So the problem was that Tor browsers that were visiting Cloudflare, which is a CDN, a content delivery network, any Tor browsers that were visiting these pages, they could be mistaken for bots just due to the anonymity of the Tor browsing network. And so they were being served up too many CAPTCHAs, when CAPTCHA is a proof of humanness, and that basically made it unusable. So the basic solution concept was that they wanted to come up with a way for one action to result in a batch of tokens. So prove your humanness once and get a batch of tokens that allows you to trade those in. And then the tokens would also provide anonymity. So this was a requirement because if you're using Tor browser, you also have the browsing anonymity. So they wanted to make sure that the tokens didn't give up that anonymity. So privacy paths, I want to give credit to other people. So the idea was originally based on Chom's eCache, which comes from 1983, quite a while ago. We all stand on the shoulders of the people behind it. I mean, people who came previously. And the concept there was you take a token, blind it, get a blind signature, and that the issuance and redemption are unlinkable. And then with privacy paths, there was a paper released in 2018, privacy paths bypassing internet challenges anonymously, and a batch of blinded tokens issued when a CAPTCHA is solved, and then multiple tokens can be redeemed later, and thus also unlinkable by Cloudflare. So this was a great solution, and we thought we could adapt it. I'll also talk quickly about the zero-knowledge cryptography involved. It's batched EC VOPRF with redemption, and that's elliptic curve, verifiable, oblivious, pseudo-random function cryptography. And it's verifiable only by the issuer redemption and batched validation for efficiency. And these use a discrete log equivalence proof, and this is a short zero-knowledge proof, in which two pairs of points have the same discrete log, and there's an equation for those of you who understand that. So yeah, it's really great that we can use zero-knowledge proofs. This gives us this concept of keeping this data separated, but being able to prove something. And so our adaptation of privacy pass is basically we did proof of payment instead of proof of humanness. We integrated it with the Tahoe Labs protocol, not Cloudflare. So Cloudflare is not involved at all with our product. Tokens, ZCAPs, in our case, this is how we refer to them, are redeemed for storage time, not web page access. And it's developed as a new separate solution, whereas the previous, whereas Privacy Pass in its original form is a browser extension. So the result, ZCAPs in practice. So how ZCAPs work in practice? ZCAPs can be used to authorize individual actions without identifying individual users. So this is a really key part to our system, that we can actually, maintain this product and accept payments, and not being able to link that data to the individual users and to be able to give them privacy is pretty amazing. We think that, yeah, zero-knowledge proofs are pretty fundamentally exciting, and when placed in the right spots and systems, that they can actually provide a level of privacy that we just couldn't have been dreamed of before. Yeah, so uses batches of blind signatures as spendable tokens, and like I mentioned before about the usage, you spend X to, in our case with private storage, you spend X amount of ZCAPs to store, Y amount of megabytes for 1 month. The exact numbers can vary, but this concept where you can spend tokens to perform a resource-limited action is fascinating and cool. So tokens cannot be linked to the token holders or each other. So even between two separate usages of the same batch of ZCAPs, those tokens can't be linked together. And so that is also very powerful because they become fungible in a sense. And then they can't be linked to the token holder itself, which is also part of the privacy preserving part. And they can't be forged, and the issuance is controlled. So from a business perspective, this has been important for us too. So here's a nice diagram that shows this a little bit, summed up a little bit better. This is what the system is without ZCAPs. So you have your customer who pays with a credit card, for example, and the credit card processor stores this information. So whether that's your company or a third party, that there's this personal data basically, and that payment data is then sent to the service to be able to do that proof of payment part of it. But that service accounting, that payment accounting data is it's able to be linked directly with the service that's actually being provided. And so with that data linked, like I said, you have less privacy there. So you can always know that linkage. And in some services, this isn't desired, like ours. And so how ZCAPs help here, you can see the similar drawing, but things have changed where we've separated those two collections of data. So the service data for the database for the payment data, that personal data with payments, is separated with the ZCAPs, the zero-knowledge proofs being there, from the actual service usage data. So in our case of storing data, that's basically like whose data, like does the data belong to that person? We can't do that because of this linkage, or unlinkage, I should say. Yeah, so that diagram, I think, also helps to illustrate how this can preserve some privacy or enhance privacy in the case of if you have those two data sets already linked. So expanding on the ZCAPs usage, we're very excited about ZCAPs, as you can tell, and we like to talk about them. And there's different types and denominations of ZCAPs that we'd like to see happen with Tahoe Labs. So in our use case, we're starting out with one type, one denomination, but in the future, it would be great to have various ones for Tahoe Labs. We also can see, we're also working on a proof of membership type implementation at the moment, in addition to the proof of payment one. So because those steps are separated, you can do things besides proof of payment. Because it's not directly tied, it's tied to the proof of payment, it's not tied to the payment itself. You could also do something like proof of membership, proof of donation, and so there's some really interesting things I think that could happen with data storage by utilizing ZCAPs and Tahoe laughs for other purposes. So we use it for our private storage product, but this could be applied in different ways. And then, even outside of Tahoe Laughs, different services and different products outside of it could be accepting ZCAPs also. So what we've done with ZCAPs could be applied to other systems. And this could enable privacy in more services. That's why we're excited about sharing information about it, because we think that it would be great to see more systems out there using it. And this could also be a potential for some limited interoperability to help solve some interoperability challenges in a privacy-preserving way. And then another thing that could be interesting to expand on the usage of ZCAPs would be a secondary market for them. Right now, the ZCAPs are just for use within private storage and that implementation, and we just sell them directly to people. But you could envision that possibly in the future there could be a secondary market where, because they're anonymous and fungible, they could be resold, for example, through special services to further provide more privacy. So there could be other disconnects in the business chain, basically, to help for more privacy. And then there's other potential use cases, like I alluded to in the previous slide, that we could see that software as a service. So other services could easily use ZCAPs as a solution for preserving privacy there and enabling that kind of separation of data between the required data that they might have to get for certain purposes, and then separating that from their service. So this is especially possible whenever the service doesn't need to be personalized. So obviously, if your service is tailored around this kind of personalization of service, then having more privacy around your users' usage of your service isn't maybe what you're looking for. But there are plenty of services out there that we interact with on a daily basis that we just naturally use personal data for, and we don't really think about it. But upon reflection, we can come to realize that a lot of services, in order to function, to give us that service, they actually don't need to know a whole lot about who we are. And so those kinds of services could really benefit from something like this. And this could also enable the acceptance of anonymous users. So there are, of course, use cases where anonymity might not be required, but there's other use cases where anonymity would be a requirement of that system to function correctly, because that creates a different level of fairness or something in the system, like voting. Although we haven't really discussed too much about the voting use case, that could be something. But yeah, there's a lot of different things that you can envision for this too. And then it could enable creation of secondary markets that, based on these, because of if you add these other steps involved, then, like I mentioned before, these secondary markets can enhance privacy also. And so that's something else for us to consider with tech. And it could be a possible on-ramp for accepting cryptocurrencies too. So just due to the nature of how ZCAPs work, they could also be very nicely integrated to accept cryptocurrencies. And that brings me to that next point about blockchain and protocol development. So ZCAP tokens are not on a blockchain. You haven't gathered that from the presentation so far because I haven't mentioned it. Yeah, and so they could function as an additional access control to infrastructure that does utilize blockchains. And so that's that kind of just the way that the nature of how they work, because they are tokens, but they're not tokens on a blockchain, that they could be integrated with blockchains and perhaps offer some interesting privacy features to some other systems out there. So yeah, ZCAPs in action. This is the interesting part. We'll be launching private storage later this year. You can sign up to be notified about that launch and interact with some ZCAPs yourself later this year. So yeah, privatestorage.io is where our product will be launching. You can read more about it on that website and also on the Least Authority website. And we're investigating offering ZCAPs as a standalone service. So we'd be very happy to hear from other people who think that ZCAPs could be useful for their tool, or just any ideas that you have. You can email us at contact@leaseauthority.com. And then I have a whole slide here of links and references. So there's some other information if you want to dig into it. And yeah, if anyone has any questions, I'll just check. Okay, so there is one question here, and it says, how does one save a ZCAP? So yeah, it depends on how you're interacting with them. In our use case with private storage, we have a desktop application that you would interact with in order to interact with private storage. So like I mentioned in the earlier slides, that we have that the encryption and the sharding and all of that kind of information that happens on the client side when you're interacting with Tahoe Labs and, in our case, private storage. And so when you're interacting on that client side, that's also where your ZCAPs would be saved to. That's where they actually get generated on the client side too, and they get stored in that application for you. So yeah, and then you just redeem them when you're sending your data to be stored. So I think you can go back to one of those previous slides. Yeah, so here when your client side is doing the data encryption and the shards, and then it would send the shards with the ZCAPs from your machine to our servers, and then our servers check, validate that they're basically ZCAPs that we issued, and if so, then it goes ahead and accepts those shards of data for storage. So your ZCAPs actually get stored locally for you. Hopefully that answered the question. And any other?
Yeah, there is on the chat from Steven 2 questions.
Yeah.
Are ZCAPs unique coin or based off Ethereum blockchain?
Yeah, hopefully I answered this towards the end there. That ZCAPs are not a unique coin. We're using the word token, not in the Ethereum token sense, or not in the blockchain token sense. We're just using it in the, I guess, pre-blockchain token sense. So yeah, ZCAPs are not a unique coin, and they are not based on the Ethereum blockchain or any blockchain. They are essentially, in our case for private storage, we create them essentially. I mean, we don't create them, but we help to create them centrally. So any plans to support integrate ZCAPs with Zcash? So yeah, that's what we would like to do in the future, definitely. So right now we're gonna, with private storage at the launch, we'll be supporting fiat currency payments through credit cards. But we definitely want to expand that. Like we had that in mind when we were basically creating ZCAPs, is that we want to do this privacy preserving kind of approach with them. And so yeah, linking them up to cryptocurrencies like Zcash is ideal. Other privacy coins could be cool too, where then you can have a more end-to-end privacy experience basically in signing up for secure storage. Yeah, any other questions? Oh yeah, it looks like.
Yeah, I think it's one from Flo.
Yeah, enabling anonymity for services that only because of their payment system currently cannot be pseudonymous sounds like an exciting opportunity, more valuable than only being able to pay in crypto coins. Any timeline for this? Yeah, I mean, the only timeline commitment that we've got right now is to launch private storage soon, and get that out into the wild for people to sign up and start using. After that, I mean, it's kind of up to the rest of the world too. If everybody's really interested in this and gives us more support to do more work like this, then we'll get things done faster too. But yeah, I mean, we'll try to get the cryptocurrency support in private storage pretty quickly. And then in terms of other people being able to use ZCAPs, I mean, I think I showed on the slide, our repos, our code repos are open. So there's nothing stopping anyone else from going and looking at the code that we've got out there for ZCAPs and utilizing it themselves, but we're also happy to talk about that and how we can better enable that in the world.